So in this session we will be discussing merge sort algorithm. So merge sort algorithm, first of all I will tell you that it is an recursive algorithm. Recursive algorithm. And as its name suggests, it is a sorting algorithm. Sorting algorithm which is used to sort arrays. It can be used to sort any type of array. It can be character array, it can be array of integers, or it can be array of string, and so on. So it can be used to sort array of any particular data type. So now you may have heard about bubble sort, insertion sort, selection sort. So these all three are other sorting algorithm. So you may be thinking that why we are studying merge sort algorithm when we already have so much of sorting algorithm. So here I must tell you that these algorithm takes big of n square time to sort an array of length n. But the merge sort algorithm is an more optimized algorithm. It is a more optimized algo. Its time complexity is much less than these three algorithms. As you can see, its there in the time complexity of these three algorithms is big of n square. But in this session, we will see that the time complexity of merge sort algorithm is much less than the time complexity of these three algorithms. So therefore, merge sort algorithm is a more optimized algo. So now we will start our session. So in this session, we will see explanation, or I can say working of merge sort algorithm. Then we will move on to pseudocode of this algorithm. And since it is an recursive algorithm, so we will do dry run for this. And after these three, we will see code for the merge sort algorithm. Once we will cover these three things, then you will be able to write code for the merge sort algorithm in any of your preferred language. But in this session, I will provide you code for any one of the particular language. So now let us start with the explanation. So you need to remember the basic key rule on which the merge sort algorithm work. So the basic key rule for the merge sort algorithm is to sort the arrays it used the game of divide and merge. It uses the concept of divide and merge. So now here I am going to write some important points about the merge sort algorithm. So it is possible that at this moment it will be hard for you to understand these points. But I will suggest you to note these points, and once I will take an example, then you will be able to link these points with that example. So for now, note these points very carefully because this is the base of the merge sort algorithm. So the most important thing, or I can say the most basic thing about the merge sort algorithm is that single element array is always sorted. That is, if I have an array of single element, let's say 9, then this array is already sorted you can't sort this array anymore. So this is very basic or important from the concept of merge sort algorithm. And now I will talk about the divide procedure, that how division take place. So it is very basic to note that in merge sort algo you will continue to divide an array until you get an single element, you get single element arrays out of it. So we will see divide procedure from the example itself. For now you need to note how we are going to divide. So now if I will talk about the merge procedure, because as I've told you there are two procedures. First one is divide and second one is a merge procedure. So in merge procedure, whenever we will get two sorted arrays, then we will merge them such that after merging the single array that you are going to get will be sorted. It means that if you will be having two sorted arrays, then you will merge these two sorted arrays to get a single sorted array. Now the next thing that I want to talk is, if you have odd numbers in your arrays, like it means that the total number of elements in your array are odd, let's say 1, 9, 13, 4, 2, 19, 7. This array has total 7 elements, and now 7 is the odd number, and if I want to divide this array into parts, then there are two possibilities. The first one is 1, 9, 13, 4, and the second one is 2, 19, 7. That is ratio of 4 is to 3, that is greatest is to smallest. And the second possibility is 1, 9, 13, 4 to 19, 7. That is the ratio is 3 is to 4, that is smallest is to greatest. So while dividing the odd number of elements array, you can use any of these procedure. So in this session we will be focusing on this procedure. So so as I have told you, you can choose any of this procedure, but not that, since merge sort is a recursive algorithm. So if you choose any particular case, then you need to fix it for your complete code. Let me just take an example so that we can connect these points with that example. So here in the example, I am taking the 9 number of elements in my array. It's 19, 12, 6, 1, 9. So you can count that there are 9 elements in my array. So if I want to sort this array by applying merge sort, then first of all we need to start with the divide procedure. Since this is not a single element array, so divide procedure enter into the game and will divide this array into two arrays. So as I have told you, it is an odd number of arrays and I am going to divide it in the ratio 5:4, that is greatest is to smallest. So the division will be like this: 17, 2, 5, 3, 19, and here I will be having 12, 6, 1, 9. And again you need to note that after each division we will first focus on left array and apply division procedure on it. Now therefore I will first focus on the left part. Now this is a 5 number element array and I will divide in the ratio of 3:2. So it is 17 to 5. Here it is 3, 19. Again I will focus on the left side array first, and here I will divide it in the ratio of 2:1. Here I will get 17 2. Here I will get 5. Now again I will focus on the left side array and again division procedure will come into the game since it is not a single element array. So division procedure will again divide it in two arrays. So it is 17 and here it is 2. So now these are single elements array and division procedure can't divide it anymore. So merge procedure will come into the game because this is a single element array, and I've told you that every single element array is a sorted array itself, and whenever you will get any two sorted arrays then you will merge them to form a sorted array. So here I will merge these two sorted array because I have got two sorted array. So merge procedure will enter into the game and merge them to form a sorted array. So now these arrays will get merged, and here I will be having 2, 17. Now you can note that this is a sorted array, this is a single element array, and since a single element array is always a sorted array, so these two arrays are sorted arrays. And now again if you have got two sorted arrays, then merge procedure will enter into the game and merge them to form a sorted array. So now merge procedure enters into the game and merge them to form a sorted array. Now if you will merge them, then the sorted array will be like 2, 5, 17. Now here we have got the sorted array. Now we will come on to this part. Now division procedure will apply on this array because this is not divided into single element array, and I have told you that division procedure will continue to apply on any array until it is divided into a single element array. So now here I will get 3 and here I will get 19. So now these are single element arrays. So these are sorted arrays. Now the merge procedure enters into the game and it will form an sorted array out of it, which will be 3, 19. Now at this step you can note that this is an sorted array and this is an sorted array. Now you have got two sorted arrays. Now whenever you got two sorted arrays at a time, then merge procedure will enter into the game and merge them to form an sorted array. So now the merging of these two arrays will carry on, and here we will get 2, 3, 5, comma 15, comma 17, comma 19. So here I have gotten sorted array. Now we will come on to this part. Now since this is not a single element array, the division procedure will apply on this part. And when it will apply on this part, then this array will get divided into these two parts, 12,6 and 1,9. Now again we will focus on the left part first. Now this is not a single element array, so division procedure will again apply on it. So here I will get 12, here I will get 6. Now you note that this is a single element array. So when this is single element array, we can say that these are sorted arrays. So whenever you get sorted arrays, now merge procedure will again enter into the game and merge them to form a sorted array. So here I will get 6, 12. Now we'll come on to this part. Since this is not a single element array, division procedure apply on it. Here I will get 1, here I will get 9. Again the merge procedure will apply on this and I will get 1, 9. Now you will note that here at this step we have got two sorted arrays, and since we have got two sorted arrays, so merge procedure will enter into the game and merge them to form a single sorted array. So here we will get 1, 6, 9, 12. Now at this step I have got two sorted arrays. So merge procedure will again enter into the game and merge these two sorted arrays to form a single sorted array. So now merging of these arrays will take place, and here I will get 1, 2, 3, 5, 6, it's 9, 12, 17 and 19. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can note that this is a 9 element array that we have earlier taken, and now at the final step we have got our sorted array. So this is our final answer, and at the final answer I have got my sorted array. So here I am taking another example of this array. This array contains 5 number of elements, and now here we will apply merge sort algorithm on this array and will try to sort this array. So now again you will note that this is not a single element array. So division procedure will enter into the game and divide it into two arrays. So it will divide it in the ratio of 3:2, greatest is to smallest, because I am choosing that here. 17, 13, 19, 21, 3, and as I have told you in this algorithm, I am choosing to focus on the left array always first. So first I will focus on the left side array, and it will get divided into two sub arrays because this is not a single element array. So division procedure will enter into the game and divide it into two arrays, 17, 13, and here it is 19. Again I will focus on the left side array first. Now this is not a single element array, so this array will get divided into two sub arrays, which is 17 and 13. Now you can note that these two arrays can't be subdivided anymore, and now since these are single element arrays and single element arrays are sorted arrays, so at this stage, at this step, I have got it two sub arrays. I can say I have got two sorted arrays, and whenever I got two sorted arrays, then I will merge them to form a single sorted array. So here I will merge them to form a single sorted array, and when I will merge them, then it will look like 13 comma 17. So at this step again, this is an sorted array. Again this is an sorted array, because single element array is always an sorted array, is always a sorted array. So at this step I have got two sorted arrays. So again I will merge them, because merge procedure says that at any step, if you will get two sorted arrays, then you will merge them to form a single sorted arrays. You can compare it with the definition that I have told you earlier. Now again I will merge them. So here I will get 13 comma 17 comma 19. Now this is an sorted array. Now I will come on to this part. Now since this is not a single element array, division procedure will apply onto this. So now it will get divided into 21 and 3. Because I have told you an array is always divided into single element arrays first. So now you can also check that at each step, at any of that step of your algo, you always got single element arrays of every element. So now at this step, coming back to this, I will note that these are two sorted arrays again. So I will merge them to form a single sorted array, which is 3 comma 21. So now at this step again I have got two sorted arrays. Now since I have got two sorted arrays, so I will merge them to form a single sorted array. So I will merge them, and noting my answer here, sorted array for this array will be, it would be 3, 13, 17, 19 and 21. So this is my answer. So at this step, explanation part is complete. So now we will move on to the pseudocode. How can we write pseudocode for this algorithm? So pseudo code. So now when we will do this algorithm, when we will perform this algorithm in the code, then we need to note that in code we can't really divide the arrays. So now you may be thinking, how can we perform merge sort if we can't divide the array? Because the main game of merge sort algorithm was dividing and merging. So here you need to note that you can't divide the array, but you can play with the index. So you may be thinking that how can you play with the index? So before writing the pseudocode, let me just give you an idea that how it is going to work. So let us consider an 5 element array. It's 1 2 3 4 5. So its index is 0 1 2 3 4. So now you note that here we need to divide this array in 3 is to 2, that is 0 1 2, and here it is 3 is to 4, 3 and 4. So here we need to divide this array into the two arrays, where in the first array you will having 3 elements, and in the second array you will be having 2 elements. So we need to divide this array into two parts. So how it can be done in the code is, you can make an function and tell that function that it need to consider the array only from 0 to 2, and this function need to consider second array from the index 3 to 4. So in this way, by telling your function the indexes from which the first array start and the first array end, and the indexes where the second array start and the second array end, you can tell your function that about which two arrays you are talking. And in this way, by using indexes, by mentioning indexes, you can divide your arrays into two sub arrays. So now let me just tell you how the pseudocode of merge sort algorithm looks. So it is merge sort and its parameter are the array to which you are applying the merge sort algo, and the second parameter is low and the third parameter is high. So what I mean by low and what I mean by high. So low means the lowest index of the array. Lowest index of your array which is 0 here. And high means the ending index. Lowest index, or I can say starting index. So I will write it here that low means starting index and high symbolizes the ending index for your array. So if I want to pass this array to merge sort algorithm in the first go, so I will pass it as merge sort array 0, 4, because in the first run the starting index of this array is 0 and starting index of ending index of this array is 4. If the merge sort will run for this array, then it will be merge sort array 0, 2. In this way, your function will get to know that about which array you are talking, and this will help you to divide your array. So now, since we know that we need to divide our arrays, I need to find the middle point about which we will divide. Now here mid will be equal to low plus high by 2. In this case, if in the first go I will calculate the mid. So let me first write the complete pseudocode so that I can make you understand with this example. So let me first write it, then here again merge sort array low mid, and here again I will call this same function merge sort, and the indexes parameters are array mid plus 1 and high. Then I will be calling another function merge, which will merge two sorted arrays to form a single sorted arrays. This is for performing the function of the merge procedure basically. So merge array low mid high. So we will talk about the code of merge procedure later on after discussing the pseudocode and dry run for the merge sort algorithm. So first we will focus on the pseudocode of merge sort algorithm. So what is happening here? Here at this point I am calculating the mid. So first, if I am calculating the mid for this array, then mid will be equal to 0 plus 4 by 2, and it comes out to be 2. So index here that we have, I can say that I am treating this mid as the index. This mid we are going to use as the index of the array. We know that 0 and 4 was the index, and I'm going to use this as the index. So now here from this I have got the mid as 2. So now I need to divide these arrays. So how will it get divided? I know that the first array will be from 0 to 2. That is, our low was 0. That is from low to mid, because mid is equal to 2 and low was equal to 0, and here we have seen that it was 0, 1 and 2. From, let me just take an previous example where I have make you understand that. Here you can note that in the previous example, its index was 0, its index was 1, its index was 2, its index was 3, its index was 4. And here in these two subarrays, the first array was from index 0 to 2. It is 0, its index is 1, it is 2. And the second array is from the index 3 to 4. Its index is 3 and its index is 4, that you can note from here. So now you can note that the first array was from 0 to 2 and the second array was from 3 to 4, and here the low is 0 because low is the starting point of the array, which is 0. So you can note that the first array will be from low to mid, and second array is 3, that starting from 3, that is mid plus 1, 2 plus 1 is 3, and it is going on till 4, and this is the ending index of this array, ending index. So I will say it to be high because I have told you high is symbolizing the ending index of an array. So it is from mid plus 1 to high. So here you can note that here I am giving my merge sort function the parameter, which is array low to mid. Low is the starting index, which is 0, and mid is the ending index, which is 2. And here I am applying the merge sort on this second array, which is whose starting index is mid plus 1, which is 3, and ending index is high, which is 4. So in this way, using the concept of mid, I have divided my arrays into two sub-arrays, and again I have applied the merge sort algorithm. That is, at these two steps, I am telling my compiler that now from this array I have got these two sub arrays, and now I need to apply again my merge sort, that is divide and merge procedure on these two arrays separately. And now here, after I have got two sub sorted arrays, then I will merge them to form a single sorted array. I know that there may be some confusion to you still now, so that will be got clear once we will discuss the dry run for this. So before going on to dry run, let me just tell you that since this is a recursive algorithm, as you can note that this function is itself calling it. So this is a recursive algorithm, and for recursive algorithm there is some condition which will break the recursion. So here you can note that the base condition comes whenever you got a single element array, because whenever you got a single element array, you can't divide this anymore and you need to backtrack, you need to go back and merge. So you need to go back and you can't go further. So this is our base condition, because you can see anywhere that when we have got single element arrays, then we have not gone further and we have backtracked. So there is backtracking whenever you got single element array. This is our base condition. So now how we will write our this condition in the code? So to write this condition in the code, you must note that for a single element array, let's say I am considering a single element array 9. So now you will note that its starting index is 0 and its ending index is 0 also. So my base condition to check and single element array will be if low is equal to high, because whenever low is equal to high, that is starting index and ending index is same, then it implies that we have got a single element array, and now here we need to stop. And for the safety purpose, I can make my condition as low greater than equal to high. So here I will write my condition that if low is greater than or equal to high, then we will return and stop our function here. So now here our pseudocode part is completed here, and this is the pseudocode for the merge sort algo. And now we will move on to dry run so that we can understand that how this pseudocode is working. And after dry run we will move on to the code of merge procedure. So let us do dry run for this and understand that how this code literally works for a given array. We will ensure that this merge sort function will work on this complete array from its lowest index 0 to its highest index 4. So as soon as you call this merge sort function, this pseudocode will start applying. Now the control come onto this line and it will check is low is greater than or equal to high. That is 0 is greater than or equal to 4. So now 0 is not greater than or equal to 4. So this is false and this function will not return here, and the control will go on to the next line. So here in this line the mid will be calculated, and here mid is 0 plus 4 by 2. So mid here comes out to be 2. So now the control will go on this line, and here again there is a call for this merge sort function, and this call is as follows: array, here the lowest index is 0 as we know, and the mid that we have calculated here is 2. So now here you must note that by this call where you have passed your lowest index as 0 and highest index as 2, you have indirectly using the index divided your array as this. The index of 17 is 0, the index of 13 is 1, the index of 19 is 2. So indirectly by passing the lowest index as 0 and the highest index as 2, you have indirectly divided your array to this. So now after this call, the control will again come to this line, and there is a second, this is the second call for the merge sort function, which is merge sort, and here we have array 0 to 2. Again again we will check this condition that is low is greater than or equal to high, that is 0 is greater than or equal to 2. No, this is false. Since this is false, this function will not return, and again the control will come onto this line, and here mid will be calculated. Now at this stage mid is 0 plus 2 upon 2, and you can note that the mid here comes out to be 1. And again the control will come on to this line, and in this line we have called the merge sort with the parameters as the array, the lowest index as 0, the middle index as 1. So now here you must note that by passing the lowest index 0 and the highest index 1, we have come to this part from this. So now at this stage, so as I've told you, at this stage the array that I have was 17, 13, 19, and now after this call the control will again go to this line. If you have some confusion that how the control from this line go to this line, then it means that you have some doubts in recursion and you need to revise that topic. So now after this call the control will again come onto this line, merge sort array, the lowest index is 0 and the highest index that we have passed from here is 1. Now the array at this stage that you have is 13 and 17. So you must note that by playing with the index you are indirectly dividing the arrays. And again, as I have told you that we will be focusing on the left part first, so this code is working according to that. You can see that we are focusing on the left part first always. Now again it will check the condition that is low is greater than or equal to high, which is 0 is greater than or equal to 1. Now again this is false though, so this function will not return and the control will come onto this line. Again now mid will calculate it here, it is 0 plus 1 by 2. Now it will come out to be 0. So you may be thinking that 0 plus 1 upon 2 arithmetically is equal to 0.5. So here I must specify that this function, that this operator gives you the integer value, that is the greatest integer function of this. And greatest integer function of 0.5 is 0. So now again the control from this line will come to this line again. And now the call is merge sort. The array that you have, the lowest index is 0 and the middle index that we have calculated here is again 0. So now this is the fourth call that I must note here. Merge sort array 0, 0. So now at this stage the array that you have is this 17. So now again the condition will be checked, that is low is greater than or equal to high. Now is 0 is greater than or equal to 0? Yes, 0 is equal to 0. So this condition is true. And since this is true, so this function will return. Now it will again return to the place from where it was called. Now again earlier we were at this stage, so now the control will come onto this line. Merge sort array mid plus 1, here is 0 plus 1, which is 1, and high at this stage is equal to 1. As you can see that here the high is 1. So now this is the fifth call, which is merge sort array 1, 1. Now you must note there that the index is 1, so the array that you have here is 13. So now you must note that earlier we were at 17 and now we have also divided the array. We have also got the 13th as our array. So now till this step we have got 13 and 17 as our two sorted arrays. So let's see what is the next step. So as we can see, according to the pseudocode, the next step is of the merge function. And now this merge function will merge these two sorted arrays to form a single sorted array. So this merge function will merge these two sorted array, that is 13 and 17, to form a single sorted array of this 13 and 17. So with the help of that merge function, we have reached to this step till now. So now as you can see, after the merge function, this function will return. This function will return to the place from where it was called. So now we are again at this step. And in this merge sort function, the next step is of this. As you can see that earlier in this function we were at the step merge sort array low and mid, and now after this the next step is of merge sort array mid plus 1 and high. So the call will be as merge sort array. Here the mid plus 1, the mid was 1, so mid plus 1 will be 2, and here the high was 2. So here as you can see that the call is for the array from beginning from 2 and ending at 2. And this array which we are talking here is 19. Because you can notice the index, that is 0, 1, 2. So this is the starting index and this is the ending index itself. So if I will take you to the diagram, then this is the diagram. Here earlier we have reached to this step of merging 13 and 17 and we have got this sorted array, and now after this call we have got this array. Now after getting this array, let's see what is the next step. So the next step is of again merging two sorted arrays. So now here these two arrays, that is 19, 13 and 17 will get merged to get this. Now we have got this sorted array with the help of the merge function. Now again you can notice that the work of this function is completed, and now this will again return to the place from where it was earlier called, that is this. And now as you can notice in this function, the next call will be of this. So let me just write it, merge sort again array, and here mid was 2 and here mid plus 1, it would be 2 plus 1 3. Again here high is 4. So now you can see that now the call that I have is merge sort array from 3 to 4. Now you can notice the array from 3 to 4 is 21 and 3. So it is 21 and 3. So if I will again take you to the diagram, then it was this 21 and 3. From that call I have reached to this array. And now what will happen, the control will transfer to this, and now this code will again start running. So again the condition will be checked, that is low is greater than or equal to high. So you can see that this condition is false. So the control will go to the next line. It is mid. So mid will be calculated here 3 plus 4 by 7. And since it acts as a greatest integer function, so 3.5's greatest integer function would be 3. So here the mid is 3. Again now the call is merge sort array mid plus 1 to I. Sorry. It's merge sort array low and mid. The call is merge sort. The array that I have, it's low. The low is 3 here and mid is again 3. So you can notice that the array that I am getting here is 3. The array that I am getting here is at the index 3, which is 21. So it's 21. So with that call I have reached here. And now you can notice that when for this call this code will be run, again the low, that is 3, is equal to 3. So here this function will again return to this. If I will show you that merge sort array 3 3, then you can note that the condition, that is 3 greater than equal to 3, is true for this, and now this function will again return to this. And now let us see what is the next goal. So the next goal is merge sort array mid plus 1 high. So if I will write here, it is merge sort array mid plus 1 is 4, and again high here was 4. So you can see that at the fourth index we have 3. So this is the array beginning from 4 index and ending at fourth index. So this is 3. Again you can note that we have got this 3 as our array. Now what is the next step after this? So after this the next step is of merging. So now when we will call the merge function, then this merge function will again merge this 21 and this 3 to 3 and 21 as a sorted array. Now after this step, after this merge function call, we have got this 3 and 21. Now again the work of this, which is merge sort array 3 and 4, is finished, and now this will return back from where it was called, that is this. And now what is the next step after this? So you can note that earlier we were at this place, so the next step after this is merging. The next step is the call for the merge function. So after the call for this merge function, what will happen, as we all know that we have got this and we have got this, and now this merge function will merge these two sorted arrays to form a single sorted array. And after merging these two sorted arrays, we are going to get this. So after this code, after the call for this merge sort function, we have got this sorted array as our answer. So I hope that this is clear to you. Here with the help of the dry run, we have seen that how with the help of the merge sort function, this array can be transformed into this sorted array. So now let us see the code for this merge function, that how this merge function was merging two sorted arrays to form a single sorted array. So merge procedure. So before proceeding to the pseudocode of this merge function, let me just tell you that how this merge procedure is merging two sorted arrays into a single sorted array. So let us consider two sorted arrays. Let me just write them. So the first sorted array that I am using here is 13, 17, 19, and the second sorted array that I will be using here is 3 and 21. So I will be using these two sorted arrays to make you understand that how this merge procedure is merging two sorted arrays to form a single sorted array. So these are two sorted arrays. So how I will merge them? So basically first we will create a temporary array to store these arrays. So I will just make a temporary array to store a single sorted array. So I have made a temporary array here, and now the idea is to put a pointer on the beginning of this array and a pointer on the beginning of this array. Now how we will proceed? Basically we are going to compare the elements where we have put the pointer. So first we will compare these elements. Now when we will compare 13 and 3, then we will find that 3 is the smallest element out of these two. So we will put 3 here. And now what we will do, we will proceed, we will increase this pointer by 1. And now we will compare 13 and 21. So you will note that 13 is smaller than 21, so you will put 13 here and increase this pointer this time by 1. Now we will compare 17 and 21. Again 17 is smaller than 21, so you will put 17 here and increase this pointer by 1 again. Now we will compare 19 and 21, and since 19 is smaller than 21, so you will put 19 here. So now here we will note that after putting 19 here, this array is completely exhausted, or I can say this array is completely visited. Now here the element which is left is 21, so that this is the element in the leftover array. So what we will do that once if an array out of these two is completely exhausted or completely visited, then we will put the elements of the leftover array as it is in this array, which is 21 here. So I will put 21 here. So I will repeat that if one array out of these two is completely exhausted, then we will put the elements of the leftover array as it is in this temporary array. And now you can note that here I have got the sorted array, the merged sorted array out of these two sorted arrays. So now let us see that how the pseudocode for this merge procedure look like. So it is merge So this merge procedure takes as parameter as the array which it need to sort, the lowest index, the middle index and the highest index. So let me just tell you the terminologies that I am going to use here. The pointer that I will be using for this left array will be named as left, and the pointer that I will be using for this right array will be named as right. And now we know that the first array is from the low to mid, and the second array is from mid plus 1 to high, which we can note from the merge sort code itself. So now here I will make an temporary array. Now the left pointer will be set at the low. You can note that initially the left pointer is set at the low and the right pointer will be set at the mid plus 1, that is here. Now I will put the condition that while left is less than or equal to mid and right is less than or equal to high. Now this condition is itself ensuring that these two arrays have elements to compare, because if left becomes greater than mid, then it means that this array is completely visited and we don't have any more elements in this array to compare. So now if these two arrays, that is the left array and right array, have elements, then what we will do that we will just compare these elements. Here the element of the left array, the element to which the right pointer is pointing. So if the element at the left pointer is less than or equal to the element at the right pointer, then what we will do, we will add that left pointer element to our temporary array and we will increase the left by 1. Now again, else, that is if left is greater than right, it means the element at the right pointer is smaller than the element at the left pointer, then what we will do, we will add that element at the right pointer to our temporary array and we will increase the right pointer by 1. Now again you note that after this loop is completed, then there is some possibility that there is some leftover array, means there is some leftover element in some array. Like here in this case, after the comparison was completed, still 21 was the element which was left here. So to put that leftover element from the leftover array to our temporary array, I need to use another loop. So the loop will be while left is less than or equal to mid. So now left is less than or equal to left. So now left is less than or equal to mid. So this loop is checking. I can write it as in the comment. This loop is checking for leftover element in left array. So if left is less than or equal to mid, then it means that there is some element which is left in the left array. So what we will do, we will just add that element in our temporary array, and we will increase the left by 1. Similarly, I will check that if there is some element which is left in the right side array, if there is some leftover element in the right array, then what we will do, we will just add that element in our temporary array, and we will just increase the right pointer by 1. So after these 3 loops, we will get our sorted array as the temporary array. And now the next step is to copy the elements of the temporary array into the actual array that we have, which is ARR here. So to copy the elements of the temporary array into the actual array, we need to write a for loop which will vary from low to high, and it will just copy the elements of temporary into the ARR. So now you may be thinking that why here I have write I minus low, why it is not ARR rise equal to temp I, why I have not done this. So you must note that this is wrong here, because there is some possibility that the array which we are actually sorting is not starting from the index 0, because in our coordinate cell we have just seen that there was a situation when we need to merge these 2 arrays, and you can note that the index of these arrays was not actually starting from 0, because the indexes here were as follows: 0, 1, 2, 3, 4. So the actual index of 21 was 3 and the actual index of 3 was 4. So in this particular scenario, if you will write this code, then it would be wrong, because the actual index of this ARR was not starting from 0, but the actual index of temp will be starting from 0, because the temporary array that you will be having will be starting from 0. But the actual index of ARR, where we need to put the element, is not starting from 0 here. So here you need to write I minus low itself, which will ensure that we will able to put the element of the temporary array at the right index of this ARR array. So here you need to write temp I minus low at place of temp I. For example, let's say we need to merge 21 and 3, and now as you can see that the index of 21 is 3 and the index of this 3 is 4. So after the merge procedure is completed, the temporary array that you will be having will be like 3 and 21. Its index would be 0 and its index would be 1. So now you note that here if you will do array I is equal to temp I, here the low is 3 and here the high of the array is 4. So if you will run your code from 3 to 4, so you must note that if you will do array 3 is equal to temp 3, then you will get some error or you will get some the error values in your array because the temp 3 actually doesn't exist, or you can say that there is some garbage value at the index 3 of this temp because this temp has 3 at its index 0 and it has 21 at its index 1. So you can't do this. Actually you need to do array 3 is equal to temp 3 minus 3, which is temp 0. You need to do array 4 is equal to temp 4 minus 3, which is temp 1. So here you must note that this 3 is a low. Therefore at place of temp I we need to do temp I minus low. So now here the code for this merge procedure is completed, and now we will move on to the Visual Studio Code to see the actual implementation of this merge sort algorithm. So here I will be writing the code for the merge sort algorithm in the C++ language, but if you have understand the concepts, then you can write its code in any of your preferred language. So let me just write the code for the merge procedure first. So here I will be making a dynamic array whose name is temp to store the sorted array. Now here I have initiated my left pointer at 0, and here I have initiated my right pointer at mid plus 1. So this pointer is for the left array and this pointer is for the right array. Now here I will code the 3 loops that I have shown you in the pseudocode. So here I have mentioned these three loops. So this first loop is for the comparison purpose, I can say. When neither of array is empty, or I can say when none of array is empty, that means both of arrays has some elements to compare, and this loop is for the purpose when there are some leftover elements in the left array. And this loop is for the leftover elements in the right array. This loop is putting the leftover elements in the right array into the temp array. And now here the last step is to copy the elements in this temporary array into the actual array ARR that we have. So here I have copied the element from temp to the required array that was given to us. So now let us write the code for this merge sort algorithm. And again you must note one thing, that in this merge function, in this merge procedure and this merge sort algorithm, you need to put the array that is given to you by reference. Don't pass it by value, because you need to pass it by reference, since by passing it with reference you will be able to make changes in your actual array. So this pass by reference will help you to make changes in the actual array. So you must pass it by reference if you want to make the changes in your given array. So let me just write the code for the merge sort algorithm, that is So here I have written the code for this merge sort function. So now in the main function I have made a dynamic array named ARR as this. The number of elements in this array is 7, and here I have printed this array that I have taken here before sorting, and then I have called this merge sort function to sort this array that I have taken here, and after calling the merge sort function I have again printed the array to show you what is the output after calling the merge function and what changes are coming after calling merge function in our actual array. So let me just run this code. So you can note that the code here is compiled successfully and the array that I have earlier before sorting is this, and after calling the merge sort function I have got this sorted array. So now I hope that the concepts of merge sort algorithm is clear to you, and before ending the lecture let me just tell you something about it, that the time complexity for this algorithm is big O of n multiply by log n. Now why it is n multiplied by log n? Log n is there because here at each step you are dividing your array into two parts, therefore it is log n, and this step is assumed to be done n times, therefore it is multiplied by n log n. Here n is the number of elements in your array. And it is not important to understand that how this time complexity is basically derived, but you need to remember the time complexity of this merge sort algorithm. Now the space complexity, if I will talk about the space complexity, then you must note that the space complexity for this algorithm is big O of n, where n is the number of elements in the given array. Now why it is big O of n? Because the extra space that we have used here is only in the form of this temporary array, and the length of this temporary array is n, which is the total number of elements in the given array. So the space complexity is big O of n and the time complexity for this algorithm is big O of log n. So now I hope that all concepts related to merge sort is clear to you. So we will end our lecture here. So see you in the next session.